Okay, so this is a quick geology in the news about the Istanbul earthquake of 23rd of April. I'll just go through the background geology and discuss the earthquake very briefly. Okay, so this is the USGS catalogue of earthquakes for the 23rd and the 24th of April in the area. There's Istanbul, there's the Sea of Marmara, and so the large one, the magnitude 6.2 earthquake, was here, centred in the Sea of Marmara, and then there have been some aftershocks up to magnitude 5 here along an axis that kind of heads towards Istanbul. At the time of recording, I'm not aware of any deaths associated with this earthquake, although there were quite a few injuries associated with people's response to the earthquake. This is the moment tensor solution that the USGS have published, and if you don't know what these are, then there's a link to videos describing that in the description of this video. But essentially, these blue quadrants are quadrants where the first motion is compressive, so motion away, outwards, and the white quadrants are the regions where the first motions were dilational, so movement inwards. Okay, so that's consistent with either this plane here sliding bottom left, top right, so along this horizontal plane, or along the north-south trending plane, you'd have right side moving north, left side moving south, and they're both consistent with this moment tensor solution. Okay. So if we look at the broader scale geology of the region, there's Turkey, there's Istanbul up there, and it's essentially part of the Alpine Himalayan system. So there's mountain chains that run through from the Pyrenees up through the Alps, running up through here, up through the Caucasus, and also then down through Turkey, Iran, and then down through the Himalayas. And this is associated with, there was a large ocean that sat here, that was the Tethys Ocean, and the closure of the Tethys Ocean in the last 40 million years or so is what's caused all of this Alpine Himalayan mountain building event. What's left of the Tethyan Ocean is essentially this little dark blue deep basin here in the eastern Mediterranean. So we're going to zoom in on this region. So we see this deep trench here. This is the Helenic Trench, and this is the last surviving subduction zone. So there's the very final bits of the Tethyan Ocean floor, which is busy subducting underneath Greece and Turkey here. Okay, and if we look at the faults in the region, all of the solid lines here are thrust faults. So these are compression, so essentially compression across the fault orientation, so largely north-south compression, consistent with subduction of an ocean along this southern seaboard. And the dotted lines are strike-slip faults. So you can see there are a lot of thrust faults in the system. Essentially, each of these blocks was a little bit of continental crust that was sitting out in the Tethyan Ocean, which has been accreted onto the southern side of Europe and are finally being incorporated into this Africa-Europe suture zone. Okay. If we look at the plate motions, then we see that Africa is moving northwards. It's being dragged north by this final bit of subduction. The Arabian block is actually moving northwards considerably faster. So these arrows, the size of the arrows, are proportional to the speed of movement, plate movement. And you can see that Turkey is moving out to the west, out of the way of this Arabian block that's moving northwards. Okay, and this is indentor tectonics, just as I discussed in the Myanmar earthquake. This is indentor tectonics happening again. So this is a strike-slip fault here. You can see that Turkey is moving down to the west, so you would expect there to be Turkey moving to the west, relatively things to the north of this strike-slip fault moving to the east, so a right lateral slip system. And this is the North Anatolian fault system that we see in this dotted line that runs through here. And you can see it goes through Istanbul and then down into the Sea of Marmara. So if we zoom in on that, there's Istanbul, there's the Sea of Marmara, and this is historical earthquakes. All these white dots are the historical earthquakes from the USGS record. So that's the magnitude 6.2 and its aftershocks. And you can see that they follow this line here like this. There's another line that runs across here. So that's those two faults here, which is the western extension of the North Anatolian fault system. That's the expected sense of slip that we just discussed on the basis of Turkey moving out to the west. And in fact, if we look at that, that one fits perfectly well with the moment-tensor solution, this moment-tensor solution from the USGS. Okay, so yes, it was a right lateral fault, strike-slip fault that we would expect on this fault that's sitting here, these historical earthquakes. So was it the big one? Magnitude 6.2 out here. That's probably a few tens of centimetres of displacement across the fault during that. And if we look at the historical record for earthquakes along the North Anatolian fault, it looks like this. So we can see this 1939 was a big thing. It had up to 6 meters of slip in it. So this is the cumulative slip here against position. And so something like the 1939 rupture, we wouldn't have had good seismic records for it. So this slip has actually been measured. So what they've done is they've gone along the fault where the 1939 rupture happened, which is this fault here. They've actually physically measured the displacement across the fault at sufficient sampling to get this displacement map, okay, this slip map, okay. The 1942 one was there on this little fault plane here, and that was basically that much slip there, up to a metre of slip. So this is cumulative, you just plot them up, so the total amount of slip there is from there down to the bottom through those two ruptures. What we can see that the average is of order 2 to 3 metres from this region here all the way through to Izmit or so. You've got about 2 metres or so of slip that has been generated seismically over the last century. So a few tens of centimetres of slip here just outside Istanbul is not very much at all. And the other thing that we can see is that the earthquakes from the 1939 earthquake onwards, things seem to be propagating in general westwards. So 1939, 42, 43, 44, then a little bit here in 1951, 1957 and 67. So things are propagating westwards. And what that means is that these regions are no longer supporting the stress. So that means that the regions where there hasn't been seismicity, there hasn't been slip, they're having to support more stress and they're more likely to rupture. So I think this 6.2 earthquake might be a wake-up call for some people, but it certainly wasn't a large one. We're still expecting something considerably bigger at some point in Istanbul. So that's the background to the 23rd of April earthquake. Thank you for listening. Hopefully soon I'll be able to do something which isn't just about earthquakes in the geology in the news. If you're interested in UK geology, do look at all of the rest of my videos, which are the things that you see when you're out in the field in the UK. Thank you.